All right. Hello, everybody, and happy Easter. Or I guess when you're viewing this, it's after Easter. So hope everybody had a great Easter weekend. This is a quick review for Activity 20. I want to thank Miss Petrosh. I think I'm saying her name right. It will be in the title of the video, so you can at least see how her name is supposed to be spelled. But I would like to thank her for making the review. I'm just going to do a quick recording of it. Hey, sweetheart.
I watch Daniel and Tiger.
We'll watch Daniel Tiger later. Mommy's making a video. Can you say hi?
No.
No? Okay. Can you put the Daniel Tiger disc up so you don't tear it up? Okay. Alright, so Activity 20 was all about simplifying radicals and radical operations. So, we'll start with simplifying, and then we'll move on to adding, subtracting, multiplying, and dividing. No sir, no sir. Okay, so we'll all right, so let's look at the guided practice first. And so there's some examples that are already worked out, and I'll explain those, and then we'll work some together. So it asks us to simplify each expression here. So what we're doing is when you take, what a radical is basically the symbol for a square root or any kind of root. So this symbol is called a radical. And right now this is our square root symbol. So when we take the square root of a perfect square, like 25, well, we're looking for something times itself that gives me 25. That number would be 5. So I could take my 25, split it into 5 times 5. So that would be the square root of 25. Okay, so then we get to things like these over here. These are not perfect squares. When we take the square root of 75, that's not a perfect square. There's not a whole number times itself that would give me 75. Okay, so square root of 75 is not a perfect square. So what we've done here is find two things that multiplied give me 75, and we made sure one of those numbers was a perfect square. So 25 times 3 gives me 75. 25 is a perfect square. The square root of 25 is 5. Okay, and then we have a 3 that's left over since we can't take a square root of 3, or we can, it's just not going to be a whole number. It's going to be a horridly irrational decimal, so we leave it in the radical. Okay, so I'm going to offer you an alternative way to do this, because my brain does not always think of perfect squares. If you think of a perfect square times another number, perfect. But if you don't, you can do what's called prime factorization. So you look for things that multiply to give you 75. And let's say you didn't think of 25 and 3. Let's say you thought of 5 and 15. 5 times 15 gives me 75. Okay, well 5 is prime, so I can split this 15 into two numbers that multiply. 5 times 3 will give me 15. So then I look for things that will, I look for two of the same factor, because remember when we take the square root, we're looking for something times itself. So 75 is the same thing as 5 times 3. I have two 5s, so that can pull out to the side. And when I take the square root of 5 times 5, that's 5. And then that 3 is left on its own. So I don't always think of perfect squares off the top of my head. Sometimes I do, but I don't always. So this is a good method for those of you that can't think of factors that happen to have a perfect square. So my dorky way of doing this, same process, you factor out, and then when you come over here, you're looking for, just bear with me, this is a silly explanation, but pretend it's prom. And at prom, they play slow jams. And when they do the slow jam, you're finding your dance partner, someone to dance with. So all the couples will become one dance partner or one dance couple. So these two are the same, so they become a couple and make it to the dance floor. And then all the single people stay in the bleachers and talk to their math teacher during prom. Hashtag true story. So there's that. Okay, so if we look at B, same process. They took the square root of 36. That's 6. 2 doesn't have a square root, so that stays in the middle. And 36 times 2 gives me the original 72. Another way to do it, they did 9 times 4 times 2. Took the square root of 9, which is 3. Took the square root of 4, which is 2. And the 2 is left alone. 3 times 2 is 6. So that's why you have the 2 the same answer right here. Okay. Alright. Same process here. 7 times the square root of 12. We can break 12 into 4 and 3. The square root of 4 is 2. 3 doesn't have a square root. Multiply that 7 and 2. This 7 times the square root of 4. You get 14 square root 3. And then in part D, same thing, but this is just variables. We split the exponent. So this is a c squared times a c to the 1, or just c. The square root of anything squared is itself. So when you take the square root of c squared, you're left with just a plain c. And then you have this plain c on the inside as well. And it's important that c has to be greater than or equal to 0 because you cannot take the square root of a negative. Can't square root a negative number. Alright, so let's look at A through E. So I'm going to use my hockey stick method or my dance partner method and split it. And I'm going to pick some numbers that aren't perfect squares right off the top of the bat. I will for some of them, but not for all of them. So you can kind of pick and choose how your brain works. Alright, so 18. Two numbers that multiply to give me 18. You could use 9 and 2 or 6 and 3. So let's use 6 and 3 here. 3 is prime, so it's not going to multiply. 6 on the other hand, or it's not going to divide, sorry. 6 I can divide into 2 times 3. So square root of 18 would be the same thing as 2 times 3 times 3. And real quick, we're not going to use that 6 because that 2 times 3 is the same thing as that 6. We split it into 2 factors. We don't want to count that twice. Okay, so I'm going to look for things that I have 2 of. And I have 2 3s. So that will come to the outside of my radical. And the 2 will stay inside. Okay. Alright, B, we're going to work on this 48. And we're going to leave the 5 alone for now. So let's look for things that multiply to give me 48. I know 12 and 4. And I can split both of these. It just kind of depends on how, again, depends on how your brain works. 12, we can divide into a couple of different things. Let's divide it into 3 and 4. And I'm going to do it this way because, look, we have 2 4s. You could divide the 4s into 2 and 2 and 2 and 2 again. But we already have a pair, so let's leave it alone. So I have a pair of 4s. I'm going to bring that to the outside of the radical. So I have 5 times 4 and then square root of 3. That 5 was from our original problem. We don't want to forget it. So 5 times 4 is 20, and we're going to leave the square root of 3 alone. Okay, 126. So I have to think of some things that multiply to give me 126. I know I can divide 126 and 2. So that's 2 and 63. Let's see, 63 I can divide by 3. And that's 21 and 3. And 21 can be divided by 7 and 3. So I'm going to take all of my prime factors. So we have 2 times 3 times 3 times 7. I'm going to take anything I have 2 of, which is that 3 and 3, and bring it to the outside of the radical. And then I have a 2 and a 7. I'm going to multiply those and leave them on the inside. Okay. So D, we have 24y squared. So y, the square root of y squared is y, but for my people who need to see it visually, remember y squared is y times y, so I have 2 of my y's. Okay, 24, I can split into 4 and 6. 4 splits into 2 and 2. 6 splits into 2 and 3. So I have 2 times 2 times 2 times 3 times y times y. And everything I have 2 of is going to come out. So I have 2 2's and 2 y's. So 2 y's on the outside. I have 1 leftover 2, and since it doesn't have a partner, it's going to stay inside. And I have a leftover 3. Those will multiply and become 6. Okay? All right, 45. We'll split into 5 and 9. 9 splits into 3 and 3. It's a perfect square. We could have used that as well. And b cubed is b times b times b. So if I were to write this, all the factors in the radical, I have a 5, 2 3's, and 3 b's. Okay, I'm going to get everything I have 2 of. Those will come out, so that's a 3 and a b. And on the inside, I have a 5 and a b left over. All right. So if we look at the next section, if we look at A, B, and C of the next section, it's very similar, except that this is a cube root. So instead of looking for pairs like I did up here, I'm looking for 3 of each number, or something I could take the cube root of. So 8, okay, let's go with 16. I'm sorry. Cube root of 16, you could split that into 8 times 2. 8 is a perfect cube, but if you didn't know that, you could split that into 2 and 4, and split your 4 into 2 and 2. So this is the cube root of 2 times 2 times 2 times 2. Okay? And you can take, it's cube root, so we're looking for 3 of a kind. So this is 2 cube root 2, which was the answer we got here. Okay? So, you can continue to do this. I'm going to skip B for now. It's basically the same thing. You split it into a cube root, and multiply whatever you pulled it, whatever you pull out of the radical, multiply it by that 3 that's at the beginning. C is interesting because it's a variable. So here they split into x cubed times x squared. 3 plus 2 is 5, so it works. You could also do x times x times x times x times x. So remember, x to the 5th is 5 x's. We're looking for 3, or a set of 3. So we have 3 x's here. Those get pulled out. And we have 2 x's left over, so those multiply and stay in. So just for the visual people that need to see it, that's why I do it that way. This, to me, in my head, makes more sense than this. And it could just be because I'm crazy, but that's fine. Okay, so A, when we simplify this expression, we're going to split it just like we did earlier. So we can do 4 and 6. 4 splits into 2 and 2. 6 splits into 2 and 3. So this is the cube root of 2 times 2 times 2 times 3. I look for 3 of a kind. And leave the single one in the bleachers, or in the radical. Okay. On B, we're going to split this. 54, we could do, let's see, 6 and 9. 6 splits into 2 and 3. 9 splits into 3 and 3. And my z cubed is z times z times z. So I'm going to take my cube root and plug in all of my prime factors, which are the ones that are at the very end. So 2 times 3 times 3 times 3 times z times z times z. I'm going to look for my 3's of a kind. So I have 3 3's. And I have 3 z's. So I have 3z is times the cube root of my lone 2. Alright, 40b. 40 I know will split into 4 and 10. 4 splits into 2 and 2. 10 splits into 2 and 5. And there are 4 b's. Okay, so we have 2, 2, 2, 5, b, 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 b. So again, sets of 3. We have 3 2's. We have 3 b's. And then on the inside, we have a 5 and a b left over. Okay, and that is simplifying radicals. I hope that was not too terribly difficult. Okay, so we're going to start now on adding and subtracting radicals. So this is very similar to adding and subtracting and combining like terms. You can only combine terms that have the same radicand or have the same number in the radical. So if I have something like the square root of a plus the square root of a, that would give me 2 square root a. But if I had the square root of a plus the square root of b, well, that's as simplified as it gets. I can't combine those. The only way I could combine those is if I could simplify that radical and get something times the square root of a, or something times the square root of b. Then you could add. Okay, so, and then we're going to tell whether or not the sum or difference is rational or irrational. If you add 2 irrational numbers, or if you add an irrational to a rational, you will get an irrational number every single time. The only way to get a rational number is to combine 2 rational numbers. Okay, so I'm going to skip here. You can read that on your own time. I think pretty much I generalized what to do with this. So let's move on to A, B, and C. We're going to add the 2 numbers in front of the square root 7. So that's 5 square root 7. And then we're going to bring that 2/3 down. Okay? And that's it. And this is irrational because we have an irrational number plus another rational number. It's not going to, it won't rationalize. So this is irrational. If you were to put this in the calculator, you're going to get a big ugly decimal. Okay, so here we're just combining like terms. So we have 5 square root 6 minus a square root 6. So we're going to remember that there is an invisible 1 in front of that square root 6. So this is 5 minus 1, which is 4. And we're going to leave times the square root of 6. Then we have a 2 square root 5 and a 7 square root 5. We add that 2 and 7 and get 9 square root 5. And again, it's 2 irrationals being combined, so this will be an irrational number. Okay. And then part C. So we have 2 square root 2 and 3 square root 2, which is going to equal 5 square root 2, plus the square root of 8, plus 2. So normally I would say we're done here, but we can simplify the square root of 8. I can multiply 2 and 4 to get 8, and multiply 2 and 2 to get 4. So this is square root of 2 times 2 times 2. So I have a pair of 2's that can come out, and another 2 that would stay in. So this 2 square root 2 replaces that square root 8. 2 square root 2 plus 5 square root 2 is 7 square root 2. And we're going to leave that plus 2 at the end because that's a rational number and I can't combine it with this. So a rational even though this is rational, I'm adding it to another irrational, and that's going to leave me with an irrational sum. All right. Okay. Let me move this a little bit. Okay, so let's look at multiplying. Multiplying is easy. It's my favorite. Because when you multiply the items that are outside, and that gives you what's outside the radical. Then you multiply what's on the inside, and that gives you the inside of the radical. And I absolutely love it, because then you're done. And then the only other thing you would have to do is simplify. Yep, and that's it. So we'll just practice with these down here. Okay, so let's just multiply. 2 times 5 is 10. And 10 times 3 is 30. And that's it. Multiply the outsides together and multiply the insides together. 30 will not, you can split this into 3 and 10. 10 splits into 2 and 5. So 3, 2, and 5, there's nothing in common. So this is simplified. Okay. So let's go to B. 3 times 2 is 6. 6 times 8 is 48. So I can simplify 48. So I'm going to do that up here where I have some room. So 8 will split into 4 and 12. And 12 will split into 4 and 3. And again, I can split those 4s further. But 4 and 4 is a pair. So we'll pull that out. So this is the same thing as 4 times the square root of 3. So this is 6 times 4 times the square root of 3. And 6 times 4 is 24. All right, let's look at C. Again, we're going to multiply the outsides, and that's 20. And I'm not sure what 12 and 18 are multiplied, but I'm pretty sure we can simplify that. So we have 12 times 18. So let's look at what multiplies to give me 12. And that would be 2 and 6. 18, I can multiply 6 and 3, and I have a pair. So we're going to take that 6 and pull it out. 6 times 20 is 120. And then that 2 and 3 are going to stay on the inside. 2 times 3 is 6. So that's kind of lazy because I didn't actually multiply the 12 and the 18. But I was just going to, once I multiplied it, I was just going to have to figure out what multiplied to get to that number anyway. So I may as well just skip that. But again, I'm a little lazy. So, and last but not least, D, we're going to multiply the outside. 3 times 2a is 6a. And then we have 5a and 15a squared. So again, I'm going to just do this 5 times 15. Even though I can easily figure out what it's going to be, I'm going to leave 5 and 15 separated so I can split it and multiply. And we've got a cubed, and I'm just going to leave it. The a times a is, or I'm sorry, a times a squared is a cubed. I am going to multiply that one. Okay, so 15 I can split into 5 and 3. And then I have a pair of 5s. So we have 5 that's pulling out, multiplied with that 6, that's 30. Okay. And then I know I'm going to have some A's, and we'll leave this 3 in here. Now I have 3 A's. Alright, so I'm going to take 2 of them, and that's going to come out. So I have an A and an A, that's A squared. And then the leftover A is going to stay here. Alright, so I know I'm moving fast. I am filming on Easter. Maybe that's my own fault. But so I know I'm moving fast, but I also don't want to waste a whole lot of your time. And again, this is review. So I know radicals were not our most favorite topic, at least not with my kids. But it is review, so it should come a little easier to you guys than it did the first time. excuse me. Alright, so we're going to move on to division, and then we'll be done. And this video will ring in right underneath 30 minutes, which is great. Okay, so when we divide radicals, it's just like multiplying. You can divide what's inside and simplify. And then you can divide the two terms on the outside and simplify. Or you can leave them in fraction form if it's already simplified. So that works out. Or you can simplify and then divide. That's what's great about these, is there's a couple of different ways you can approach it. So I'm going to skip these, and I'll just show you straight up how to work these here. So 4 divided by 5 does not work. That's a simplified fraction. 42 divided by 6 is 7. So this becomes, you can write this one of two ways. Let me change that. So you could do, because that's really ugly, you could do 4 times the square root of 7 over 5, or you can write it as 4/5 times the square root of 7. Those are equivalent. It's the same thing. This is saying you multiply 4 times the square root of 7, then divide by 5. This one's saying 4 divided by 5, then times the square root of 7. And you would get the same thing either way. Okay, part B. 10 divided by 2. Well, 10 divided by 2 is 5. 54 divided by 2 is 27. So we've got 5 times the square root of 27. And this can be simplified some. So 27 can be multiplied by 9 and 3. 9 can be split into 3 and 3. So I'm going to take my pair of 3's out, multiply it by the 5 that's also on the outside. And that becomes 15 times the square root of that 3 that's by itself. All right. Okay, let's look at C. 12 divided by 3 is 4 times the square root of 75 divided by 3. And 75 divided by 3 is 25. And 25 is a perfect square. So this is 4 times the square root of 25 is 5. And 4 times 5 is 20. And it's okay to go from radicals to no radical. It just, this one happened to divide up into a perfect square, which is awesome. Okay, so let's look at D. We have 16 divided by 8. 16 divided by 8 is 2. In my radical, we have the cube root of 8. And then we have 11, or x to the 11th over x squared. And if you remember, when you have exponents and you're trying to simplify, if you've got them in a division fraction like this, we would subtract the exponents. So 11 minus 2 is 9. Okay, and then we can simplify this. So 8 splits into 2 and 4 splits into 2 and 2. And then we have 9 x's. So this becomes 2 times 2 times 2 times x. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I have, it's a cube root, so I'm looking for 3's. So I have 3 2's times this 2 that's already out. So that's going to be 4. And then I have 1, 2, or I have a set of x's, so that's x. Another set, so that's x squared. And a third set, so that's x cubed. And that leaves me with nothing in the radical. So my final answer is just going to be 4x cubed. Okay, so made it in under 30 minutes. So that's always awesome. Thank you again to Miss Petrosh. I know I'm not saying her name correctly, and I apologize for that, but I want to thank her for making the review. And so yeah, and I want to thank all of the people who have recorded on this Unit 4 review. And if you have any questions, feel free to email any of your teachers, or even if I'm not your teacher, if you just want to email me and be like, hey, can you re-explain something? I'm more than happy to. So hope you guys have a great evening. Hope you are staying healthy and safe, and I will have videos for you soon. Bye.